Evet. Çok teşekkür ederim. Öncelikle göstermiş olduğunuz ilgiden dolayı. Bugün sizlerle MongoDB'yi konuşacağız. Biz kara danışmanlık olarak MongoDB'nin Türkiye'deki temsilcisiyiz. Ve bu webinarı MongoDB ile beraber yapıyoruz. MongoDB'den 3 arkadaşımız bizimle beraber olacaklar. Ve size hem MongoDB'yi anlatacaklar hem de bir demomuz olacak. Türkiye'de ilk defa yapıyoruz bu anlatımı, bu webinarı. Daha önce MongoDB ile ilgili webinar yapmıştık ama tamamen kendimizin prezentasyonu şeklindeydi. Ama bu sefer reel bir webinar yapacağız. Başlığında MongoDB hakkında her şey olarak koyduk. Kara danışmanlık ve MongoDB'nin beraber hazırladığı bir webinar bu. Ben Ertan Erışık, Kara Danışmanlık kurucusu ve genel müdürüyüm. Birazdan kendimizle anlatacağım ama ondan önce kısaca biz tablo temsilcisiyiz, birazdan anlatacağım. Ama tablo ve diğer konularda MongoDB bunların içerisinde düzenli olarak webinarlar yapıyoruz. Bu webinarlarımızı sizleri de bekleriz muhakkak. Duyuru listemizde varsınızdır. E-maillerinize duyurularımız geliyor. 2 haftada bir tablo konusunda webinar yapıyoruz. 2 haftada bir MongoDB konusunda bundan sonra yapmak istiyoruz. Ve diğer konularda da webinarlarımız devam edecek, bekliyoruz. Bunun yanında webinar sonrası bir anket yapılacak. O ankete katılımınız bizim için çok önemli, geri bildirimleriniz çok önemli. Çünkü hem webinarlarımızın contentlerini, içeriklerini buna göre belirliyoruz. Hem de performansımızı çok ciddi anlamda bu vermiş olduğunuz geri bildirimlere göre değerlendiriyoruz ve daha iyisini yapmaya çalışıyoruz. Dolayısıyla size göndereceğimiz anketlerimizi doldurursanız, objektif olarak doldurursanız çok memnun oluruz. Webinarımız sırasında sorularınızı Q&A kısmından her zaman iletebilirsiniz. Türkçe ya da İngilizce sorabilirsiniz, sorun değil. Türkçe sorduğunuz soruları arkadaşlarıma ben İngilizce olarak iletebilirim. Direkt olarak İngilizce de sorabilirsiniz. MongoDB'den arkadaşlar size yardımcı olacaklardır. Ben de yardımcı olacağım elbette. Şöyle bir gündemimiz var. Yaklaşık 90 dakika ayırdık. Daha uzun sürebilir ya da daha kısa sürebilir. Biraz da şeyimize bağlı olmak üzere, soru ve cevaplara bağlı olmak üzere. Ben kısa bir giriş yapacağım. Daha sonra Stefan ve Tomislav MongoDB'den arkadaşlarımız bir MongoDB Overview anlatacaklar bize. Enterprise Advanced lisanslaması ile beraber. Daha sonra ondan sonra bir Ops Manager demosu olacak. Bizim yönetim aracımız Ops Manager. Bunu Tomislav yapacak. Daha sonra biraz spesifik use case'lerden bahsedeceğiz. MongoDB nerelerde kullanılıyor, kimler kullanıyor, hangi amaçlarla kullanılıyor. Ronan yapacak bu sunum anlatımı. Ve danışmanlık hizmetlerini anlatacak MongoDB. Çünkü özellikle MongoDB'nin kendi danışmanlığını da aslında özellikle bugünlerde uzaktan almak mümkün. O konularda da Stefan bilgi verecek. Ve bir Q&A session'ımız olacak. Ama sorularınızı tabii ki prezentasyonlar sırasında da iletebilirsiniz. Toplu olarak Q&A kısmında yanıtlayacağız. Ben Türkçe yapacağım, benim kendi tarafımı. Daha sonra MongoDB'ci arkadaşlara devredeceğim, Stefan'a devredeceğim sözü ve onlar İngilizce devam edecekler. Sorry, Stefan, I started in Turkish, but I will switch to English when you take the presentation. Okay.
Thank you, Ertan.
Evet. Kara danışmanlık 12. yılında biz müşterilerimize veri yönetimi ve iş zekası konularında yardımcı olmaya çalışıyoruz. Database bizim özel uzmanlık alanımız, uzmanlık alanımızda olan konulardan bir tanesi. Ama sadece database ile ilgili çalışmıyoruz. Çok kısaca kendimizdeki ürünlerden bahsetmek istiyorum. Biz bir tablo iş ortağıyız Türkiye'de. Türkiye'deki en büyük ve bölgedeki en büyük iş ortağıyız. Gold iş ortağıyız tablonun. Ama tablonun yanında analitik veri tabanı, SQL veri tabanımız Exasol mevcut. Yüksek performanslı veri ambarı analitik projelerinde kullandığımız Exasol mevcut. Bugün konuşacağımız genel amaçlı veri tabanımız MongoDB üzerinde yoğun olarak çalışıyoruz. Ve bütün bu verileri bir araya getireceğimiz Talent ürünün de Türkiye'deki tek temsilcisiyiz. Talent'te çok geniş bir veri yönetim platformu ve bu konuda da yoğun beklentilerimiz var. Pazarda da çok ciddi anlamda şansımız olduğunu düşünüyoruz. Çok kısaca hizmetlerimizden bahsetmek istiyorum. Biz iş zekası konusunda tablo eğitimi, iş zekası ihtiyaç analizi, hızlı başlangıç ve veri ambarı modelleme gibi konularda hizmetler sunuyoruz. ETL konusunda Talent ve veri ambarı konusunda ihtiyaç analizi, veri hazırlama ve temizlik danışmanlığı yapıyoruz. Ve Talent için uygulama eğitimi yapıyoruz. Ama tabii bugünkü konumuz MongoDB. MongoDB konularında veri modelleme danışmanlığını kara danışmanlık olarak biz veriyoruz. Performans iyileştirme, DBA eğitim, giriş seviyesi eğitimini veriyoruz. Ve teknik mimarinin belirlenmesinde müşterilerimize yardımcı olmaya çalışıyoruz. Dediğim gibi bu webinar ve prezentasyonlar sırasında her zaman sorularınızı yanıtlamaya hazırız. Çok da heyecanlıyız. Oldukça da büyük bir ilgi var katılımcılar açısından. Umarım verimli ve faydalı bir webinar olur ve ben şimdi sözü Stefan'a vermek istiyorum. So, Stefan, that's what I want to share, and I can
thank you.
I can leave it to you.
Thanks for that, Ertan. What I'll do is I will share my screen. I've put together obviously some slides that cover the agenda that you've very kindly gone through. Please let me know, Ertan, can you let me know once you can actually see the slides?
Yeah, we can see the slides at the moment now.
Perfect. So, hi everyone. My name is Stephen Matthews. I'd be a senior account executive at MongoDB. Obviously, we're going to be covering the partnership between Kara and MongoDB, and Ertan has given an overview of what Kara can offer. We've had very successful partnership to date and hope for that to continue. But with a focus on MongoDB, so the main focus for MongoDB is that it's built for developer productivity. And what that means is that with MongoDB, you effectively get an intelligent data platform. And I guess what does that mean for you? So with MongoDB, given that it has the document model, it allows your developers to work with data in the best way possible. It allows them to develop their applications quicker, get into the market faster, and basically having a better return on investment for you as a business. So rather than being confined to rows and columns which are linked to every relational database in the world, the document model is a much more intuitive and natural way which allows you to innovate quicker, modify and iterate, and effectively query anything that you require. On top of that, you also can intelligently put data where you need it. So due to the distributed design of MongoDB, it allows you to store data across multiple data centers, but also you can also partition or shard as your business grows. And then finally, you can see the freedom to run anywhere. So you can run MongoDB, whether it's on a laptop, your own data center, or in the public cloud, and giving you huge amounts of flexibility. And here at MongoDB, we're constantly developing our own offering. So you can see since 3.4 to 3.6, and we've just released 4.4, there's constant new developments, new features that's going into MongoDB that makes their developers much more effective and productive in their job. And I just wanted to highlight that we've also been named as the big data leader in the big data NoSQL from Forrester Wave, and you can see that we are the leader within this field, and the sort of the main points are highlighted due to our data types, our consistency, transactions, and a lot of these points Tomislav and Ronan will be going through in further detail later in the presentation. And we have seen that MongoDB, it is increasing in popularity, and you can see that through the number of downloads. And this year so far, it does seem that it's going to continue on this trend with worldwide downloads for covering more and more use cases. And once we look at the developer community, where we have an extremely strong presence and we have a great relationship with the developer community, for the 4th year in a row, we've actually been voted the most wanted database. So what things to consider when you're looking at a database? You want to understand the toolings that make you more efficient, so the likes of automation, things that remove the manual work from yourself. Of course, you want a database that's fully secure and can meet all compliance regulations. For any mission critical applications, quite often a license will be required, and as well as that support. And of course, our consultancy services that can help not only validate you for your design phase, get you ready for going into production, but also to make sure that you can scale as your business and your applications are a success. So looking at MongoDB Enterprise Advanced, which is our enterprise license that gives you all the tooling that is required, the support that would be needed for any revenue generating applications, as well as giving you the commercial license and access to other toolings and features that would help you going forward. So Tomislav is going to go through these points in further detail, but I just want to give you an overview of what's included. So Ops Manager is our enterprise tooling that gives you all the monitoring and alerting that is required to understand the health of the database. Gives you query optimization to give you a good understanding of where improvements can be made. It includes a fully managed backup service. It's giving you the option to have point-in-time restore, queryable backups, and removes a lot of the manual work from maintaining the database by giving you that automation and configuration. Compass gives you a way to navigate through your data to help with visualizing, exploration in your ad hoc queries. BI Connector is a way to link in with some of the BI tools, just as Ertan was touching on earlier, where you can actually leverage the tools that you've already invested in to help visualize your MongoDB data, but visualize it in your already purchased SQL-based BI tools. And for the license, we also have access to the Kubernetes operator, so you can deploy in Kubernetes containers that really make things a lot easier to manage. On top of that, we have our enterprise support, which you can see. What I'm going to do is I'm going to pass this over to Tomislav to go through some of the key areas that we feel that is really important to you as a business. And then we'll be following that, we're going through a quick demonstration of Ops Manager, just so you can visually see how easy it is to navigate through Ops Manager. And we'll cover the points that we've touched on today. Thank you. Tomislav, can you take it from here and I can direct you through?
Sure. So let me first introduce myself. My name is Tomislav Bartolin. I'm a senior solution architect based in Dublin, and I support EMEA corporate sales as a technical solution architect. So yes, like Steven mentioned earlier, I'll be taking a deeper dive into some of the important features of MongoDB Enterprise Advanced Platform. And also I'll give you a quick demo of our Ops Manager tooling that you can use to manage your MongoDB deployments. So Stephen, maybe I can take over screen sharing so that I can, just continue to demo later on, if that works for you.
I think that'd probably be easiest. Yep.
Okay. Just a second.
Thank you. And just while Tomislav is bringing up the same slides again, is there any questions on anything that's being covered that anyone wants to ask right now?
Okay, if there are no questions, I'll get going then. I hope everyone can see my screen. Just a quick confirmation, please. Stephen?
Not yet.
No? Sorry, just a sec then. Oh, okay, should be fine now.
Looking good.
Okay, cool. So before we start looking at specific features, I thought it might be worthwhile just spending a few moments giving a high-level overview of how a typical MongoDB deployment looks like, because some of the topics that we'll be talking about later when we take a look at individual features might not be familiar to everyone in the audience. So yes, this is kind of simple view for a typical deployment where we can highlight some important features of MongoDB. For example, you can see that according to best practices to achieve high availability, we always recommend running MongoDB not as a standalone instance, but as a replica set, where a replica set is basically a set of nodes that are working together. There is replication going on between them, and there is a primary node in a replica set, and all the data is being replicated to secondaries. So that means you will always have multiple copies of your data, which is a good thing if something happens to this primary node. And there is always additional secondary nodes that can step in and do automatic failover, so that the applications or services, any clients that are using the database, the replica set, won't even notice any downtime. So this is a big important way which we can achieve high availability. On top of that, MongoDB also has native and built-in horizontal scalability capabilities in the form of sharding. So you can see here that I have multiple shards, and what each shard is, it's actually a partition of data. So it's similar to how partitioning works in a relational world. Basically, every shard is responsible for a portion of the total data set, and this way we can achieve almost unlimited scalability, because you can always add more shards when there is demand for increased capacity on the database. And important to note as well is that each shard is actually a replica set in itself, because we also want to ensure high availability of individual shards, because now each shard is responsible for a portion of data. So the data is not copied between shards. That wouldn't achieve anything, right? So yeah, each shard is a replica set, and it has the same high availability guarantees that a normal replica set has. On top of that, we also have an abstraction layer in form of MongoS query routers, which are processes which run alongside sharded clusters, and applications communicate with these routers, or proxy servers, if you like, reverse proxies, which means that applications don't need to be changed if your cluster topology changes. So you can start with a basic replica set, and then as demand on capacity increases, you want to scale out, you can add switch to a sharded cluster, and you won't have to change your applications, because applications never talk directly to individual shards. They talk to these query routers, and then the query routers, MongoS's, they take care of all the complexity to understand how to actually query the requests to the correct shards and where to actually find the data, right? So there is a lot of complexity there in the system, but it's all being taken care of by the database. And there is no additional tools, no additional setup that you need to do to achieve this kind of very scalable and highly available setup. I'll be talking later more specifically about these analytics nodes and what can be achieved by that. So I won't go into more detail about that now at this slide. Okay, so moving on. We feel that it's important to emphasize that we have transaction support in MongoDB. So this is especially useful for companies that are used to working with relational databases where transactions are always supported, available, and typically this is something that people feel they need when they're moving to a NoSQL database such as MongoDB. They would still like to utilize transactions. So the good news is that in version 4.0 we introduced transactions on a replica set. So as you can see, there is an application here depicted here, and there is a driver. There is always a driver in the picture because applications talk to drivers, and we have drivers for a large number of programming languages, Java, C#, Python, you name it. So there is always a nice experience for the people developing the applications. They don't necessarily need to know all the details and all the complexity that that involves, in the protocol of the speaking to a MongoS cluster, because drivers can take away a lot of that complexity. So you get drivers tailored for use for specific languages, and you can, for example, in C# you can use things like awaits and everything that's, all the features of C# language are built into the driver, right? Following on this, there was additional investment in version 4.2, where we now support distributed transactions. When I say distributed, I mean transactions across shards in a sharded cluster. So this is kind of a big thing, because this is the first time you can actually achieve a consistent transaction in such a scenario where you have horizontally partitioned data. And yes, so everything remains the same. There is no changes in the applications that you need to do. There is a lot of investment that we made on the server side to actually support this. So as you can see, I mentioned earlier these MongoS query routers that sit between driver and the application and the actual sharded cluster. So this picture gives a nice view of that. This is for anyone familiar with programming. This is how typical code using transactions in MongoDB would look like. This is just a basic Java example where you can see that the principle and the logic is very similar to how you would work with transactions in a relational database. So this should be immediately familiar to any developers who actually use transactions with SQL Server or Oracle or any other database, right? So you don't get this kind of experience with other NoSQL databases. That's why we think MongoDB is an ideal replacement for relational systems, because you get all these benefits and features of a distributed database. I mentioned earlier high availability, horizontal scalability, but the experience for developers will be very, very familiar, and it's not that hard to make the switch and move to MongoDB. And again, you get all these nice benefits, operational benefits, and also the benefits of the document model. So you don't have to work with object relational mapping tools anymore. You can save your objects from your code directly to database in the document format that MongoDB supports. Some examples where distributed transactions might come in, might be useful. Some payment processing where you're updating multiple security positions or multiple accounts. Some event processing scenarios, perhaps orders, suppliers, chains, and things like that. So these are all scenarios where, yeah, transactions could be useful. with MongoDB, it's not always we don't always look at transactions as the first way of building things, because with MongoDB's document model, typically you can embed more data that's accessed together in a single document, and by that you mitigate the need for actually joining multiple data from multiple tables, because joins are inherently slow. They slow down the system and they introduce complexity. So with the document model, we have best practices around data modeling that can just minimize the actual need for transactions, and then that can ultimately help with the performance of systems or applications using MongoDB. Okay, moving on. So we realized that it's important to open the world of MongoDB data to people who are using BI tools, for example, Tableau or Qlik or something like that. So MongoDB doesn't natively speak SQL. MongoDB has its own MongoDB query language, which is more suited to modern, query patterns and practices. But we are not trying to replace all the investment in these great BI tools that's out there. And there's a lot of people who know how to use these tools. They are good. So we just wanted to open up MongoDB data for these tools. That's why we created a MongoDB connector for BI. Which is actually a kind of translator process which sits between clients, BI tools, or anything else that speaks SQL, and the MongoDB cluster. And this BI connector will translate SQL queries into Mongo query language to get the data from MongoDB, and can also do it the other way around, so return data in SQL format to relational format to any clients using it. So it's a nice thing to have if you just want to continue using your BI tools with MongoDB. Kind of tying to this topic of BI analytics is this concept we call workload isolation. This is typically a big problem in traditional databases, because you would use some kind of ETL process to actually offload data from your operational cluster and load it into a data warehouse or some other system where you're actually running your analytics. This is just because you don't want to affect your operational transactional workload with any analytics you're doing. Analytics can be very bad for just destroying all the cache things in memory and all the performance optimizations that databases can do with query plans and caching. So you can actually employ this workload isolation pattern in MongoDB, where you have a dedicated set of nodes. You remember how I mentioned that each replica set has multiple nodes? So you can actually provision additional nodes that will be used exclusively to serve operational needs. One set of nodes will keep serving the operational needs. And then you can have this additional set of nodes that will serve the analytics or workload. So this is all live data, as I mentioned, because there is a replication taking place in almost real time between primary node and secondaries. So these analytics nodes would be just a specific kind of secondaries. So they would get real-time data updates, and any analytics you're running on these nodes means you're running it on live data. So there is no ETL process that needs to happen. For example, you might have some ETL running overnight, which means that any analytics you are running on your data warehouse or any other system where you're doing these analytics queries is basically doing it on stale data. So this is definitely an advantage we see of MongoDB in form of workload isolation. How this ties to BI specifically, I think it's nicely depicted here on this slide, where you have some transactional application that is. Oh, sorry, I need to go back. you have this transactional application, which is using this subset of operational nodes. There is always just one primary, because MongoDB is a highly consistent database. So it's not a multi-master system where you can have inconsistencies in your data. So there is always one primary, and the transactional applications can use this primary. And if something happens to this primary, there will be these secondary nodes to step in. Automatic failover will be performed. And at the same time, you can provision additional analytics nodes, which are then can be used by BI tools via the BI connector, or you can do anything else that you need the data for. You can do some data science, predictive analytics with Python, with Spark, or anything like that. And yes, you can use the same MongoDB query language to query these analytics nodes, or you can use BI connector to enable you to use SQL type queries on the cluster data. This is just another technical implementation detail, how this would be set up in a typical replica set. Anyone familiar with setting up MongoDB will recognize this, but for anyone who's not familiar, I'll just say that all this can be automated in our operational tooling, Ops Manager, which we'll take a quick look at a bit later. So this is something that you don't have to do manually via shell, via scripts. It can all be automated using the tooling we have. Okay, so moving on to MongoDB Charts. So we felt that there needs to be an easy way to visualize data in MongoDB. So BI tools are great, but we also have a native solution in the form of charts, MongoDB Charts, where you can actually you can deploy them. It's a separate kind of process, server application. You can deploy either on-prem, or we have a fully managed offering in the cloud as well. And you can connect these charts directly to your MongoDB clusters and use MongoDB query language to set up your charts, dashboards, and get a nice visual representation of your data. So this can be useful in many scenarios, and we are always improving this, adding new features. This is just indicating some of the chart types that are already available, and you can see them here. So yes, this could be used in various scenarios where you want to make better decisions by visualizing data. You can have some standard dashboards for people to use and immediately get visual information from. So yes, so I won't go into all details here, but I hope it gives you an idea about all the possibilities that you can do with this native charting solution that we have. Okay, so next I would like to move on to some of the enterprise security features we have. So this was recently introduced, client-side field-level encryption. So what this is about, it's actually a way of encrypting data on the client side, on the side of the application, so that it never leaves the client side, the application side, unencrypted, and there is no risk of data exposure on the server side. If somebody gains access to your database server, they could potentially see the data. So yes, this is useful for some scenarios where you want to encrypt the data on the field level, where you just have maybe some smaller subset of sensitive data, and you just want to encrypt those specific fields. It's great because it can actually be set up automatically. You just specify which fields you want encrypted, and then the drivers, which have this logic built in, can do the job for you. So you don't have to manually encrypt the fields that you want to be encrypted. It can all be taken care by drivers, and you need to provide a key management service. So currently we support Amazon AWS KMS, or you can have a local key store where you can store the master encryption key, and then the driver will actually use this this key to encrypt the data, right? So this is kind of more technical visualization of the flow that happens here. So you have, let's say you have some patient information, and there is a social security number for patient. You want to encrypt this so that it cannot be, used in the wrong way, and you can set up client-side field-level encryption, where the MongoDB driver will talk to the key manager to get the encryption key. And so when the data travels to the server side, this is a MongoDB cluster, it will be in an encryption form. You can see here that we have a JSON document, and we have some fields that are not encrypted, that are not sensitive data, first name, last name, but we have some fields that we encrypted using this feature, and they are just in ciphertext scrambled form here on the server side. So whenever you do this, you write data gets encrypted automatically. Important to notice that when the data is queried, it will be automatically decrypted by the driver again, so that you never have to deal with any manual encryption or decryption on the application side. This can be also useful for some scenarios where you want to forget some sensitive data, because you don't have to necessarily delete it from your documents. You can just change or delete the master key, and all the data that was previously encrypted with that master key will be basically, it won't be decryptable anymore. So you don't have to worry about that. Anyone can find some useful information in some older data that you might have backed up or moved to some other MongoDB cluster for archival purposes. Okay, hopefully that was useful to highlight all the benefits of client-side field-level encryption. And we have some other enterprise security features. This is talking about auditing, where you can actually audit all the activity on the MongoDB cluster. You can track DDL, DML commands, so anything that happens on the data or any changes to the structure of the data that can be audited. And you can get an audit log, so you can always do analysis or just figure out what happened, who made which changes and things like that. So this is all configurable. You can specify which users roles can do this, and you can create filters, just audit specific fields or documents or collections. Okay. Next we have Ldap integration. So this is typically used by customers who already have some centralized database or security management solution, like Active Directory for people using Microsoft servers and Microsoft platform, where you can actually configure MongoDB to use Ldap integration to talk to your Active Directory server and get users and roles from there. So you don't have to configure them separately on MongoDB side, which is just introducing potentially unnecessary overhead of maintaining user information in two separate places. So this is something that can be really useful to prevent those bad things, right? Yes, so you can even use Kerberos Authentication if that's what makes sense. So Kerberos can be used for authentication, and then you can configure for authorization. You can configure it using Ldap in Active Directory, where you can map your Active Directory groups to MongoDB roles. so that you configure user permissions on the Active Directory side, and that will be just applied to MongoDB's role-based access control system via this Ldap integration. Okay, next, I would like to just give you some information about MongoDB Enterprise Operator for Kubernetes. So we see a lot of interest and a lot of move to a containerized based world, right, where people, apart from their applications, they also want to run MongoDB database inside Kubernetes, or just to kind of unify everything, have a single deployment platform. So to simplify and streamline that experience, we created a custom operator for Kubernetes, which can easily enable you to deploy MongoDB inside Kubernetes clusters. And it just enables you to use standard Kubernetes tooling like YAML configuration files or CLI tools like kube control to manage MongoDB clusters. You can even deploy MongoDB Ops Manager inside Kubernetes, so you don't have to install and manage Ops Manager tooling separately. It can also be handled by the operator and run inside Kubernetes clusters. Okay, so this leads us to MongoDB Ops Manager. So I've mentioned it multiple times already. So while MongoDB clusters are distributed database and they have a nice structure that is maintainable even by using shell and manual scripts. Sometimes there is, or in any serious environment, there is always a need to have something more easier to manage. So that's why we created this Ops Manager tool, which helps you to perform various aspects of maintaining or managing your MongoDB deployment. You have monitoring with a lot of metrics, performance indicators that you can track. You can even connect. There is an API that's exposed from the Ops Manager, so you can integrate Ops Manager with your existing APM tools to get information from Ops Manager and MongoDB in that way. MongoDB Ops Manager can also provide some optimization guidelines or recommendations. I'm going to show you that feature a bit later when we go into the demo. And probably the most important thing is automation. So you can handle any cluster configuration changes through Ops Manager. I've shown you the script which would be used to add additional and configure analytics nodes in the cluster. So all that can be automated through Ops Manager. All the knowledge, all the scripting and tools has been embedded into Ops Manager, and you can do all that through Ops Manager to change your cluster topology, resize the cluster, add additional nodes, change the version, upgrade from one version to another. And it's just enabling you to reduce the operational overhead of actually running MongoDB. And backup, as a final note there, backup is obviously important. So Ops Manager has a built-in continuous backup feature, which means you can achieve near zero RPO objective because data is continuously backed up, and you can restore to any point in time in the last 24 hours. Or you obviously have snapshots. You can define a schedule for snapshots, but we're going to take a look at that just a moment later in the demo when we look at Ops Manager. So yes, I'm going to stop presenting at this point. I'm going to move to the actual Ops Manager deployment. Yes.
Just a second, I will make a comment about what's going on so far in Turkish. Thank you. Şimdi çok teşekkürler. şu ana kadar olan sabrınız için. Bütün bu anlattıklarınız, yani Stephen'dan başlayarak anlatılan her şey aslında MongoDB'nin Enterprise Advanced paketi içerisinde gelen özellikler. Ve open source MongoDB içerisinde deneyebileceğiniz ama lisanslamanız gereken özellikler, daha doğrusu open source paketi içerisinde olmayan Enterprise Advanced paketi içerisinde olan özellikler. Ops Manager'da bunlardan bir tanesi ama şu ana kadar anlatılanların hepsi bu paketin içerisinde olan özelliklerdi. Sorry. Go ahead, please. Thank you very much.
No problem. Are there any questions maybe at this point, or we want to leave questions for?
There's a question for pricing for Kubernetes deployments.
Yes, maybe we can, Steven, maybe we can talk about that a bit later.
I can. I can touch on it very, very quickly. So the Kubernetes operator would be part of our RAM pool pricing. So it's definitely something that we should talk about maybe on a separate call, but thank you for sharing. And Ertan, if you can take action to maybe follow up to discuss further.
Sure, I will.
Thanks for that, Tomislav. That was very comprehensive. And if any other questions come in, please share them into the chat and we can maybe discuss as we go on or in the Q&A session at the end. Thank you.
Okay, so I'm gonna move on now to the actual demo. So what you can see here is the landing page of MongoDB Ops Manager. So it's a UI web application that hides all the complexity of the underlying tooling and services that are running to manage your MongoDB deployment. I've already prepared test replica set that's being managed by this MongoDB Ops Manager installation. So if I go here, this is kind of overview of the deployment, but I can go here and see the actual servers that are involved in the deployment. So when you install Ops Manager, you basically install agent services on servers. So that can be either a physical server or a VM, or even a stateful pod in a Kubernetes deployment. And these agents communicate with the central Ops Manager server, which then coordinates all the actions. And as I mentioned before, it can take input from either this application or from the API that's also exposed to make changes and to manage the deployment. Right. So you can see here, I'm running all this on my machine. Actually, I have a VM running, and I have some Docker containers that are acting as servers. Right. So I have 3 containers, 3 servers here running Linux. And you can see that I have an agent installed on each server, and there is a communication going on between these agents and the Ops Manager. So this is a typical 3-node replica set. So 3 nodes is actually the minimum you can have in a replica set, because the failover process in a replica set involves voting process. So if a node fails, there has to be a majority of nodes remaining in the replica set to elect a new primary. So in this scenario, you can see that this is actually the primary now, this server here, indicated by the P here, and these 2 servers or nodes are secondaries. So if anything happens to this primary, I have a fault tolerance of 1 server with a 3-node replica set. Because if something happens here with this primary, it can be either a hardware failure, the underlying machine server can fail, or it can be some software problem, operating system or MongoDB process, anything. There will be election process kicking in, and one of these remaining nodes will be elected as a new primary. And the replica set will remain functional, fully operational, and the the applications using the replica set won't see any downtime. Okay, so this is a server view, and yes, we can take a look at the actual agents running on the servers, their status when they were pinged. So there is constant communication between agents and the Ops Manager. And yes, I can configure security here. So MongoDB can supports role-based access control. So you can create users and roles to secure your collections and your data on an individual collection level, right? So what I would like to do next, just to get something going on here, I'm gonna start a script that will actually run some load on the cluster. So I have that prepared here in my Linux shell. I'm just gonna start the, oh, sorry. Oh, I have to change the directory. Sorry, a second. Okay, so I'm running this script that's just issuing some queries on the cluster that will enable me to show you some of the features that can be offered by Ops Manager. I'm gonna move back to the actual Ops Manager application now. So yes, if we go inside this test replica set, you can again see that there is 3 nodes involved here, and you can see which version of MongoDB they're using. So I've left this on version 4.0 because I want to show you the process of upgrading to higher version. So the last supported version currently is 4.2. So I'm going to do that in a moment, and we're going to upgrade this replica set to 4.2 MongoDB version, right? The next view that we can take a look at is the real-time view. So now I have that script running. We should be able to see some real-time performance data being displayed here. It's just taking some time for the system to analyze and capture this. So yes, you can see some key metrics here, like CPU utilization, disk utilization, and memory utilization. And you can also, this is just useful for a quick overview look at the cluster to see, you know, are there any problems, what's going on. You can see which collections are being used the most. So all that information is available here. And this is again useful for a quick look into the system status of your cluster. When you need a more detailed look, you can go to the metrics tab, where we show all the metrics that are available. So these metrics can be either MongoDB specific metrics, like metrics about documents, how many documents are inserted, retrieved, updated, query targeting, replication lag, all those metrics that can help you better understand what's going on with your MongoDB cluster. And there is also hardware metrics that can be viewed, metrics around CPU usage, disk usage, and things like that. So yeah, I'm gonna just turn on some additional metrics here, that you can see how easily it is to do that. And yes, this is useful for taking a deeper, closer look. You can also change the display what you're looking at. So you can go back in time and take a look at specific periods of time when maybe there was some performance bottleneck or some problem, and you can go to that moment in time and take a closer look at the metrics and maybe see what was going on, right? Okay, so this is kind of introduction to all the metrics functionality that we have in Ops Manager. We also have a data view here. where you can do some quick interaction with your data in the cluster. So this can be useful if you need to do some ad hoc operations. We have other tools that are better suited for more in-depth work with data. We have MongoDB Compass, which is actually a free tool aimed at developers. So you can download that freely, and you can use it to do some typical development tasks like insert data manually for some maybe testing purposes, or you can delete data, you can create indexes, and do some basic analytics as well. Right? Actually, I'm surprised that I don't see any data here. So let me see. Okay. Yeah. I won't go into more detail here. So that's the idea behind the data tab, and performance advisor. So actually, I think I'll have to. I think I've when I restored the virtual machine, it seems it didn't load the test data set. So just a second here. I'm gonna load some test data in the system. This will only take a moment. So, okay. Here you can see I'm using, anyone familiar with the Mongo shell can see that I'm using Mongo restore tool to restore data to this cluster. And we have some sample database containing Airbnb data with listings and reviews and things like that. So okay, we restored some data. Let's now run the script again, the load script. So okay. Yeah, so this should give us some information now in the performance advisor, because I have some really bad queries running here, just to be able to show you what happens when you've issuing some queries that are not optimized. They're not using the correct indexing strategy, and then Ops Manager has built-in monitoring that can see this and highlight it in that performance advisor view. So I'm just going to give the system a couple of moments to actually analyze this data that's going on now. And in the meantime, I'm going to walk you through the remaining functionality here. So I've mentioned already the access management features. So we have users, we have roles in MongoDB, and I also mentioned there is an API that you can use from Ops Manager. So you can, to manage access to that API, you can use API keys, where you need to create an API key for any client that wants to use the Ops Manager API. So that's supported through here. Next, a few words on backup. So as I mentioned before, Ops Manager supports continuous backup. So this gives you continuous backup of your data, and which means you can go back to really any point in time in the last 24 hours. And so the backup is turned on for this cluster. And you can see I can restore from a backup. So I have multiple options. I can restore a snapshot that has been taken, a full snapshot, or I can restore from a specific point in time. If let's say there was some data corruption, by mistake somebody deleted some data from the cluster, some documents, and you don't want to necessarily restore the whole snapshot, everything. You just want to restore from that specific point in time, that before the actual corruption happened, to mitigate or minimize the data loss. So you can do this by using this point in time restore feature, or you can even restore based on the oplog timestamp. So every operation that happens, every write operation that happens in MongoDB is captured in this oplog journal. So you can you can actually narrow down your restore to a specific operation if you have information, about which actual operation caused the problem and you want to restore before that, right? Okay, so I won't initiate this now because it will just restore the data, and I don't want to lose the sample data I've just loaded. You can also see there is restore history here, and yes, you can actually modify the snapshot schedule. So when the snapshots are taken, so currently I have that configured. These are just the defaults, 24 hours snapshot. Every 24 hours there is a snapshot taken. The minimum value here for a snapshot is 6. And you can also choose the retention period for these snapshots. So I can preserve this snapshot for 5 days here. And there is a separate schedule you can configure for daily snapshots, weekly snapshots, and monthly snapshots. So this gives you a lot of flexibility in terms of your backup management. Also, I feel it's important to mention that this backup works now fully with even sharded clusters. So any kind of deployment you have, be it a replica set, be it a sharded cluster, Ops Manager is capable of taking a consistent backup, even if you're using distributed transactions. So there is some coordination that takes place between Ops Manager and the cluster that ensures that there is a consistent backup taken from all the shards. You remember how I mentioned that each shard contains a portion of data. So typically it's a very it can be a cumbersome process to take consistent backups with manual tools like MongoDump and MongoRestore, and that's why this backup feature in Ops Manager is very useful, because it's easy and you are guaranteed that all the backups you take will be consistent and there won't be any problems. If you're using sharded clusters or distributed transactions. There is also activity feed here, so you can see all the actions that have happened here, be it in the Ops Manager. You can see that there is an entry here, user accessed the performance advisor, which can potentially expose sensitive information. So obviously you can configure who has access to Ops Manager so that only authorized people can do that. But this is just to give you an idea that really everything is audited and preserved here in the activity feed, so you can always see what happened with your deployment. There's some agent-related events and things like that, or the authorization events that are shown here. Also, we have alerts. So alerts actually enable you to be alerted when something happens with your deployment. So you can configure alerts here. So you can see that there is a lot of possible alerts that can be configured. So some of them that are related to replica sets, for example, when there is a new primary elected in the replica set, we can add an alert for that. And then you can configure methods how you want this alert to be delivered, right? So you can see here that we have some integrations built in. So typical delivery mechanisms are here, like email, and I don't have it here now, but we can actually configure text messages, SMS, and also we have some integration with tools like Slack, Datadog, PagerDuty, and such, that you can get your alerts delivered there, right? Okay, so I'm just going to click the default here, email, and for this election of new primary alert, if I save that, yeah, there is no alerts now, but the alert settings are here. Here are my alerts that have been configured, and I can also configure maintenance windows, so that you don't get alerted if there is some normal maintenance taking place. Like, for example, you are doing some hardware maintenance or changing the topology of your cluster. You can configure a maintenance window so that alerts are basically silenced and you don't get bothered by unnecessary alerts because you know what's going on, right? Okay, so that's alerting, and there's just a lot of settings that you can also configure here in this settings page. What's turned on, what's not. I won't go into all the details here. I think at this point we can go back to the actual replica set view, and we should be able to see that there's some data now after I loaded the test sample data set. Yes, you can see that there is around 90 megabytes of data in the database now, and I should be able to see the database and collections. Like I mentioned, I've loaded a sample Airbnb database where I have listings and reviews collection, and you can do some basic data tasks here, like query, get some quick insights into your data, and you can query this data. You can add documents and insert documents, delete documents, and things like that. So performance advisor, let's see if we can get some information there now. Oh yes, so as I mentioned, I'm running some really unoptimized queries in the background on this cluster, and that has been recognized by the performance advisor. So performance advisor here is actually recommending me some indexes that I need to create. So indexes are always the best way to improve read performance in any database, and so the same applies for MongoDB, where you can see that I'm doing some queries based on this description field in my documents, and yeah, I don't have correct index configured, so Ops Manager recognized that, and it's suggesting me which indexes I need to create to optimize these queries and achieve better performance. Okay, I think that was the main points I wanted to show you about. Oh, sorry, I also wanted to do an upgrade of the replica set version. So let's do that. So if I go here to overview, deployment, my replica set, I can actually modify it. So currently it's using this 4.0 version. I can set the feature compatibility flag here and also change the main version of the nodes to 4.2.8 enterprise version. And yeah, that's basically it. I just changed this in the replica set configuration, and I can click save. And then I get this notification. I have unpublished changes on the cluster, and it's showing me which changes I'm making. So I'm moving from this version to 4.2, and I can confirm and deploy the changes. So if I do this, you can see that the Ops Manager is actually doing these tasks now. So yeah, we're going to come back in a few seconds when this is refreshed. But basically what's happening, there is a rolling upgrade process in place. So we don't want to have downtime when an upgrade happens. So this rolling upgrade process will ensure that, because when we have replica set, we have multiple nodes, and we can take down nodes one by one, apply new binaries. So new version comes with new binaries, new files we need to install. So Ops Manager will coordinate that whole process. It will take down node one by one, apply new binaries, do all the other tasks, and then bring the node up again one by one. And that way, in a 3-node replica set, we won't see a downtime, because there will always be 2 nodes that are active and can serve client requests at the same time while a single node is being upgraded. That's another benefit of replica sets. So high availability doesn't just mean, when there is problems, when something bad happens, you don't have downtime. It's also helpful for these kind of normal maintenance scenarios, management scenarios where you are just upgrading your version, for example.
Thanks, Tomislav.
Yeah.
Just while you're speaking of, I guess, rolling upgrades, and you were touching on ACID transactions previously, there's just been a question that has just come in that I think would be good to address now.
Mm-hmm.
It was, is there any case or situation that we can lose data even if we have multiple nodes in a replica set?
MongoDB can be fully consistent. So you can prevent data loss in any scenario by configuring the appropriate write and read concerns. So these are configuration settings you can apply on your application side. So if you use write concern majority, that means that you'll get a acknowledgement from the server only when a majority of the nodes in the cluster have accepted the write, and it has been applied, in their storage. It's durable, and even after that, if a single node fails, the data will still be preserved. So yes, by applying the appropriate set of write concerns and read concerns, you can ensure that there won't be any data loss that can happen. So obviously, if you get an operation acknowledged from the server, you can rest assured that the data will be durable. But if there is no acknowledgement, it's just normal that you have to retry the operation, or there's some problem with the database. In case there is a major problem, major outage, and majority of the nodes are down, then obviously there is a problem, and the replica set won't work anymore, right? But you can always add additional nodes to replica set to increase the fault tolerance. So three nodes is just the minimum. More nodes can be added. And also what we typically recommend as best practice, you don't want to host all your nodes. If you're hosting in your own data center, you don't want to host that on a single server. You want to distribute that maybe across different server racks, so that even if there is a full server failure, you can other nodes will survive. Or people have multiple data centers. Companies have multiple data centers where you can have a portion of your nodes in one data center and other subset of your nodes in the second one, like primary and maybe DR site. And then even if you lose the whole data center, your replica set can still work, because there will be copy of data in the other data center. So there are various options we can do there to just address. First, we need to see what the requirements are, but there is definitely all the options to ensure and to achieve any goal are there, right? We can make it happen. Okay, so while I was talking about this, it seems that Ops Manager finished this operation, and you can see now that the version has been changed to 4.2.8. And yes, let's just confirm that here in the server view. Sorry, server view won't give us that information. Oh, we can see it here, but what I was actually looking to do was go here in the replica set, where we have kind of logical node view, and you can see that each node, each agent is now reporting that the version has been upgraded to 4.2.8, right, in our 3-node replica set.
Thanks, Tomislav.
Yes.
And just before we go on any further, just if you go back to the server view there, there was just a quick question around, is there preferred operating system?
MongoDB can run, that's what we like to say, anywhere. So there is no preferred operating system. Typically, most people use it on Linux, but you can use it on Windows or even Macintosh if you want.
Perfect. And just in the matter of time, maybe we can finish the remainder of the questions at the end of the session. But have you anything else you'd like to cover off, Tomislav?
No, I hope I covered everything that was of interest here. And yes, I think that's all I have from my side, for the demo.
That's great. That was really comprehensive, and I hope everyone found it really useful. Moving on to the next section.
Do you want to take over screen sharing?
I think if Ronan was to take over screen sharing, it might be easiest, and then we could just leave it with Ronan until the end.
Okay, I'm going to stop sharing now.
Thank you.
Thanks, guys. Okay, can you see my screen okay? Okay. Thanks a million, guys. So my name is Ronan. I'm a senior account executive here at Mongo. And I just wanted to take a few minutes to discuss some of the use cases we've seen across our customers. So as a modern general purpose database, MongoDB is designed to allow you to work with lots of different types of data and by extension to cater for a wide range of use cases. This means that Mongo can not just meet your technical requirements, but also deliver on a wide range of business needs. So at a high level, we've grouped these into use cases based upon what we've seen from our customers. And from what you can see here, things like legacy modernization and mainframe offloading. These are kind of areas we see a lot of our large enterprise customers using MongoDB as an opportunity to modernize their stack, and also allows companies to meet and deliver new products and services to their customers. We also see customers leveraging Mongo to gain valuable insights across all of their data sources and types, which again can feed into the wider business in terms of understanding their customers, and also leveraging Mongo in other areas such as IoT and blockchain. So that's a nice bit of text, but what does this actually look like in terms of our customers? So here we kind of want to show you what things look like in terms of the customers we actually work with. So you can see we work with some of the largest companies in the world across a very wide range of geographies and industries, and of course use cases. So in particular here you can see legacy modernization in particular, with a lot of major institutions migrating away from relational databases. And I think overall this slide shows how Mongo as a general purpose database meets the wide range of use cases across a lot of companies and industries. And of course, we wouldn't be able to have such a wide breadth of these use cases if it weren't for our partners who support and facilitate a lot of the deals that we work with these customers. So this is kind of like a good high level snapshot. So over the next couple of slides, I just want to take 3 different customers we've worked with and dig into them in a little bit more detail to give you a sense of how they've used Mongo. So in the first use case we have here, we've Citibank, who I'm sure many of you are aware of as a global financial institution. So they faced a particular challenge where one of their applications wasn't meeting SLAs when delivering data to traders. And the impact to the business was they were receiving fines from the SEC and also damage in terms of the customer's trust of the overall service. The application itself was a relatively complex piece of infrastructure. It meant it was expensive and time consuming to maintain. So in this instance, Citi engaged with our teams and they made the decision to re-platform to MongoDB. So the ability to place data close to their customers simply and quickly, reducing latency, resulted in Citi not only being able to meet their SLAs and therefore avoid fines. The re-platforming resulted in $40 million in cost savings over 5 years, so quite significant. So MongoDB in this instance able to meet the technical requirements, but also bring in real value to Citi's customers and to the Citi business itself. In our next example, and this is more an instance where a company decided to build a new application as opposed to a refactor. So Man AHL, they're a London-based investment management company, heavily invested in technology. So much so that they found that using existing solutions in the market was expensive and really didn't give them the flexibility they needed to compete with the competition. So in this case, Man AHL, they built their own platform entirely underpinned by MongoDB. And for Man AHL, the flexible data model and scalability delivered on their need to be more agile. And also the rich query language, secondary indexes, and strong consistency meant it could cater for the wide range of use cases that they wanted to bring onto Mongo. And the result here for Man AHL was faster query times. Their throughput for ticker data increased 25-fold. And they were also able to realize cost savings of 40% by using commodity hardware. So again, a little bit of a different scenario in terms of a new application, but ultimately bringing legacy data onto Mongo, which resulted in better customer experience, meeting their technical requirements, but also delivering real value to the business. And then the last one I just want to touch on is Barclays, be one of our flagship customers, and a pretty interesting story here. So they wanted to reduce their reliance on aging mainframe systems by moving their customer data onto more agile and resilient, I should say, data platform. So like many large banks, Barclays faced significant challenges in terms of meeting customer demands for new digital products and services, while they were still relying on their legacy infrastructure. So most of their critical applications were on mainframes, and for them that created a single point of failure, and then they did experience some service outages as a result of this setup, which impacted their customers in terms of their ability to make payments. So Barclays set out to kind of prevent this from happening again, and then try to understand how they could access customer data when mainframe systems became unavailable. So when they analyzed their digital channels, revealed that 92% of traffic was generated by 25 interaction types, and 85% of these were read-only. So what Barclays did was they created an operational data store based on Mongo, and this sat between their digital services, such as their online and mobile banking applications, and their mainframe systems. So MongoDB is the operational data layer. It updated in real time via Exchange, data capture, and messaging queues to power existing applications, new services that we're also building, and other APIs. So using this operational data layer, it was possible to retrieve large volumes of transactions almost immediately. The document structure of Mongo allowed denormalized data, and this ultimately reduced complexity while also increasing performance. And the very first use case they had was customers originally were only able to see a subset of transactions of their own, like banking transactions, because they couldn't store and serve up that much data. But now if a customer wants to see all their transactions, for example, and that have the words ATM in it over the last 2.5 years, they're able to serve that up effectively in milliseconds. So the data layer powered by Mongo not only delivers the resilience and reduced their reliance on the mainframe, which was what they originally set out to do, as well as supporting regulatory compliance, but now it's the first protocol for customer data, and it's enabling a host of new digital services for their customers, and has become a strategic element of how they want to grow as a business, with Mongo underpinning a key part of that technology. So that's the last use case. I hope these examples have kind of given you a sense of how other customers that we worked with have used MongoDB in different cases. If anybody has any questions that they want to follow up on, or lots of different use cases with different customers, and I'm sure we can share them with you if there's any that you want to discuss. Thanks.
Thanks for that, Ronan. And Ronan, if you can maybe go to the next slide, that'd be really helpful. So I think that what Ronan gave a really good overview of, I guess, the number of use cases that MongoDB can address, but there seem to be really two common themes across those examples that he shared. Was a lot of customers were experiencing issues with whether it's modernizing legacy applications or trying to build a modern application to address a new need of their customer base. And from those projects that arose, those customers have always engaged with MongoDB consultancy services, and also have engaged with their partners to really ensure that the project is success from the start, and also can grow successfully and avoid any issues in the future. Ronan, can you just click to the next slide? Thank you. So with MongoDB, given the current situation, we've been able to build many packages that allow these consultancy services being delivered remotely. And what we've seen customers getting the best success out of this is firstly working with us and the partner with Kara. So you can get, I guess, local support, but also getting the expertise support from MongoDB. So we can help in terms of, I guess, design and developing your new or refactoring applications to make sure that you're, I guess, following best practices and help with the design of the MongoDB architecture. We can help ensure that your Enterprise Advanced is set up correctly, but also for any applications that might be already running on MongoDB, working with us, you can help optimize the overall application to help improve performance, whether it is improving efficiency to get cost savings or just to expand into new regions to ensure that it is scalable to, I guess, extend your reach to your customers. So I just wanted to make it fully aware that we have these pre-built packages that can help you right now, but also can work alongside Kara to help serve all your needs, whether you're in planning phase, development phase, or also already in production. We have something that can help you today. So I think with just in the matter of time, if anything does trigger your interest, or if there are any questions, I see that there are some questions that we can address right now. But if anything, if you do want any further discussions with ourselves or with Kara, please follow up with us. We're more than happy to facilitate any further discussions. And we really look forward to working with you all. Just in the matter of time, I'm just going to run through a couple of the questions, and Tomislav, if you can maybe shed a bit further light on them. One of them was just stating, can we access transactional data if all nodes collapse?
So if you lose all nodes in the replica set, then no, the data won't be available. But as I mentioned before, that's why we typically see people distribute nodes in a way to achieve their required fault tolerance level, right? So be it different servers, be it different data centers, or even multi-regional deployments, where you have you can have fault tolerance even if you lose a whole region and all the data centers there, right? So there are various options, but in general, replica set works only if there is a majority of nodes still available. So that can be that's the guideline there, right? So all the decisions have to take that into account about where to place the nodes and everything, right?
Thank you. I've seen a couple of questions around MongoDB Enterprise Kubernetes operator. We can have that discussion offline. It is part of our Enterprise Advanced license, so maybe if you could follow up with Kara and we can have that discussion. One of the questions, Tomislav, is why should we choose MongoDB instead of Cassandra for IoT, and also why we should choose MongoDB instead of Elasticsearch for single view? Maybe if you can just add a little bit of context then. I am conscious of time, so...
Yeah, I mean, this isn't a question we can answer, in like one sentence. So the MongoDB and Cassandra are different databases, have different designs and different, data models and everything. So it's not a simple answer, right? So it all depends what you're looking to get. So MongoDB has a document data model. You can employ documents typically play well with IoT use cases where you can even do some things like bucketing to consolidate your IoT data into single documents, and also MongoDB has richer query functionality, so you can more easily use the data, right? So Cassandra has very limited querying capability. So it all depends what you actually need. So I'm afraid it's not. I can't answer it as a simple one sentence.
I think if it is something that you would like to evaluate further, please don't hesitate to contact us and we can have that discussion in further detail.
Yeah, I mean, the same applies to Elasticsearch, right? So Elasticsearch started as a search engine. It wasn't designed to be a full-blown database. So MongoDB again has some features that are just not available in Elasticsearch, and things like consistency. So you can't. There is always just eventual consistency with Elasticsearch and Cassandra as well. So for people moving from a relational database, that typically won't work because it means they have to completely re-architecture their applications and take this eventual consistency into account, right?
Perfect. Thanks, Tomislav. And I think with that would be come to concluding the webinar today. I hope you all found it very useful. If there is anything you would want to evaluate or discuss with us further, please do not hesitate to reach out to ourselves or Cara. We look forward to working with you and talking with you in the future. Ertan, is there anything you want to add just before we finish up?
Yeah, let me cover it up.
Thank you.
Thank you very much for this today's webinar, Stefan. It was very useful for me. Çok teşekkür ederim katılımcılara. Umarım faydalı olmuştur. Yani umarım altını çizmek istediğimiz şeyler sizler için de faydalı olmuştur. Bundan sonra herhangi bir sorunuz olması durumunda gerek lisanslama ile ilgili, gerek ürünlerle ve MongoDB ile ilgili olarak biz her zaman yardıma hazırız. Ne zaman dilerseniz bizimle iletişime geçebilirsiniz. Bunu ya da benzer bir şeyi, content'i, içeriği sizin için de tekrarlamak isteriz. Başlangıçta söylediğim gibi bundan sonra webinarlarımız MongoDB konusunda daha detaylı olarak devam edecek. Geçmişte daha prezentasyon usulü webinarlar yapıyorduk ama daha pratiğe yönelik webinarlara devam edeceğiz. Ve dediğim gibi her zaman sorularınızı yanıtlamaya hazırız. Çok teşekkür ediyorum katılımınız için. Thank you very much, you guys.
Thank you.